What's up, YouTubers? So I have a quick video today where I'm going to answer a viewer's question regarding grounds or earths and kind of how to not become a part of the circuit per se and prevent shocking yourself. But I haven't really covered this, so I thought, well, why not? It's worth, a little short dive into it to explain some things and give you guys some idea. So let's get into it. So I'll put up the viewer's question right now so that you guys can read it and then we can all be on the same page. But basically the guy's asking, how do you properly ground something like a floor pan in a vehicle that you're welding in? And not only that, how do you not become part of the circuit? Which kind of made me laugh because if you've been welding long enough, you've definitely become part of the welding circuit a time or two. So it'll definitely get your attention. But that's a great question and something I really haven't talked about much. And, like everything, it takes time to get through ideas, but I figured, well, why not discuss this now? So that's why we're going to do that. So if you've been watching my channel for any amount of time, you've seen me test welds and all sorts of things on my welding tabletop. And basically the whole top becomes part of the electrical circuit, and my ground goes over here on this copper wire here, which I got that from a junk shop, I guess. I don't know what they were doing with it, but whatever. So I generally clamp it there. This whole thing becomes an electrical circuit or part of it. Now when you MIG weld and your wires feeding into your metal like this, the electricity flows into that and then over to there, or depending on your polarity, it may actually come through here to the wire or what have you. That's a whole topic for another video, but you get the simple idea is that it's part of electrical circuit. Well, what you can run into with cases like what this gentleman is asking about is that if you weld a floor pan in or some kind of oddball thing like that you're welding on, the electricity may follow a path that you didn't intend it to. And what I mean by that is that there's an old adage which electricity follows the path of least resistance. Well, that's kind of wrong. It follows multiple paths. It flows kind of like lightning per se. It's not just one bolt. There's all sorts of fingers that kind of come out. It may, like with lightning, once it establishes a solid path, it may, most of the current goes through that, but it still flows out kind of like trees, I guess, like branches. Well, when you're welding something like a floor pan in, where you have like multiple tacks around, what can happen is as you're welding, the electricity, rather than going from, say, this point right here to here, may go through this way to get over to return the power to complete the circuit. That can be undesirable because if you have a computer that's grounded over here, electricity in theory can go through that computer and then try and return back to the ground. That is why, it's very common when you weld on vehicles, they say disconnect the battery. By disconnecting the battery, you're reducing the chances of using a computer or some circuit as part of the path to return power to the welder. Now, it's pretty uncommon to fry a computer by welding on a car. It can definitely happen. I've personally never done it, but I have heard of it happening. Generally speaking, you got to be pretty careless. The most common way that would happen is if your ground is loosely attached over here, or you foolishly hooked to something that was actually isolated from what you're welding. So a good example, say you're welding in a trunk and you attach this ground clamp to, I don't know, some piece of metal that the car amplifier is attached to, and basically it's not actually attached to a ground. And what I mean by that is it's isolated, so that what happens is the only path to return electricity back to the welder is through the ground on the amplifier. Well, you might blow that ground wire up, essentially. So if you hook to something solid near where you're welding, you're probably all right in that case, but it's always best to disconnect the battery if you want to be safe. So let's go a little bit more in depth on this. I'm going to give you a couple options in this guy's particular situation of what he should probably do. So I'm going to start out by saying, make sure that you have a decent ground clamp on your machine. So this is what I use on my Dynasty. It's a big, heavy duty, kind of like cast, maybe, well, it almost looks forged, doesn't matter. A brass ground clamp with an extremely strong spring. These cheaper stamped steel ones can be okay if the spring pressure is okay, but honestly, this is far, far better. So have a good ground clamp. The next thing that you really want to concern yourself with is you don't, like in the case of a floor pan or really any auto body, don't just clamp this sucker right on a panel with paint on it and think it's going to work. At a bare minimum, the resistance is going to be fairly high, and it's going to have to arc through that paint to your ground clamp. That arcing is going to cause distortion of whatever this is hooked to. It may blow a hole in that. And not only that, it may have enough resistance at that point that it'll find a different path to ground or to return power, and that wouldn't be very good either. So, aka could use you as a path. So make sure you're clamped to something clean. Now, the next question you're obviously thinking is, well, on a floor pan, what do you clamp to? Because it's just a flat floor, you know, with a hump in it probably for the transmission, and there might not be anything to clamp to. Well, my number one recommendation in that case is probably clamp to a seatbelt bolt. So the bolt that holds the seatbelt into the floor, that would probably be a good location. Clean the paint around the bolt and then clamp to that. So the one caveat to that is if you're running a high enough amperage, which, well, auto body, you generally aren't running very high amperage, you could theoretically cause a short between the bolt and the threaded insert that it bolts to, which could permanently affix that bolt to that. So you want to be careful with that you don't go running, like if you're welding on a frame of an old pickup truck and you're using the seatbelt bolt as a location for ground, expect to fuse that to the nut, I guess. So you want to be careful with that. Another great option that you would have is what I have in front of me. I bought two of these because I've been meaning to either make one of these or buy one, but this is a magnetic ground clamp. Let's take a look a little bit closer at this. So these are really simple devices. What you do is you have a very strong magnet here. I mean, this thing is actually surprisingly strong. I would say at least maybe 30 pounds of pull strength, 25, but this is also a big heavy chunk of steel it's attached to. But it's really simple. You clamp a cable, so it could be your ground clamp from your welder, or you basically could just take this and clamp it to that. This holds it to the sheet metal, and then you adjust this point, which is like a copper or bronze point, to where it's just touching the material. And this then forms your ground, so it goes to there. On auto body sheet metal, putting this in the center of the floor pan and then welding all around it would be a good way to establish a really solid ground without having to worry about like clamping to bolts or anything else. So this is a solid option. Now, it goes without saying there's a couple potential problems with this. One, if you weld too close to this magnet, like say you took like this over here, right? And you put this on there and then welded it, the heat from this, as this gets stupidly hot, will demagnetize permanently the magnet in here if this gets too hot. Now, unless you have a device to remagnetize this, you'll wreck it. So that's unfortunate. These aren't really that good for certain jobs, like I said, for that. Now, the second issue is that magnetism affects the arc. And what I mean by that is this is a very powerful magnet. If you think you're going to put this on a floor pan or even something like that, and then you're going to weld right here, what you're going to experience is you're going to probably get what's known as arc blow. So if you're stick welding, you're definitely going to get arc blow. If you're TIG welding, the arc will literally start jumping over towards the magnet. So if you're anywhere near welding Where this is, the arc is not going to perform the way you expect it to. It can cause issues. So that's something to think of. On a big ass floor pan in a vehicle, probably not an issue. But a smaller, coupon like that or something, it definitely will be. So important to think of that. Now, another thing, like with that floor pan issue, something I would recommend is actually possibly using 2 of these. And what I mean by that is you could have this one with a cable off of it linked to that one, and then this ground clamp would be on here. Now, I know you're asking yourself, why the hell would you do that? But by having multiple grounding points on something like a floor pan, so you'd have one in the middle of the pan and then one on the outside, if the electricity chooses to take a path that isn't what to you is a direct path, say from here to there, and it decides to go around here and then back, by having 2 grounding points will help keep your arc stable. That's more of an issue, I would honestly say, with stick welding than MIG or TIG really, but it can affect pretty much any welding process where if you have a momentary change in where the electricity is flowing to for your return path to your welder, you can get arc wandering, and you don't want that because it's going to cause you to produce poor welds. So again, it's something to think of. So my recommendation, these were pretty cheap. I don't know, 10, 15 bucks. If you pick up 2 of these and a couple 3 feet of welding cable, like number 4, number 6, something like that, link the 2 together and then use your ground clamp to clamp to it, like I said, it'll give you a lot of options for welding on unusual, pieces where you can't really ground, especially auto body, and it should give you better arc performance, so less wandering arc. It's just something to think of and consider. Now, I'll be honest, I've done welding for years without anything like this, and I haven't really had much of a problem, and I've never shorted out any kind of engine computer or computer assembly. Could it happen? Absolutely. My main reason for buying these is to show you guys, and you know what? It would come in handy. I mean, there's been times where I will take a bare copper wire like welding cable, so with no jacket on it, wrap it around something like a tube and use that to weld to, where this could have came in handy had I just had one, and well, I didn't. So well, let's go and talk about a couple more things and go to conclusion. So now I want to talk a little bit about safety. And I get it, you don't want to hear about safety, and I don't really want to preach it. But when you're dealing with electricity, there's no doubt it can be dangerous, and there's no doubt you can electrocute yourself, or at a very minimum, shock yourself and possibly get burned, which is why I think this is really important. So I'd appreciate it if you stuck around and listened to what I had to say rather than skipping ahead. So when you're playing with electricity, there's a saying that I have. The higher the voltage, the higher the amperage, the more dangerous it becomes. And that's universally. I mean, any idiot knows that, right? Well, when you're welding with MIG, especially, you don't realize how much power you actually are inputting into something. Now, it's fairly low voltage, which that's a plus, because the higher the voltage, the more likely you are to get shocked through, say, your clothing or through your gloves. So the fact that MIG, TIG, stick operates at low voltage is good. However, you don't want to be part of the circuit. So anything you can do to avoid that is preferred, obviously. One of those things, and I'll say it right off, if you wear metal wedding rings or metal banded watches, any of that, take that shit off. I'm not joking. I'll spare you the details and the pictures because I don't want to get banned off of YouTube. But if you have any doubt of the danger of wearing a wedding ring that's metal and welding, Google it. It's not pretty, and it's very common to where someone will get shocked to their wedding ring, and it can basically deglove your finger of sorts. That's all I'm going to say. If you're a sick individual, you can go and look at what happens. So the moral of the story is, do not wear metal jewelry. Do not wear a metal chain, any of that. The second important thing is that we're all animals. We sweat when we're hot. When you're wearing a hood on your head and gloves, you're probably going to be more prone to sweating, and hopefully you're not an idiot and you're wearing some FR clothing or at least something that's decent to cover yourself from UV exposure, let alone the sparks and burns. But if you are sweating profusely and it leaches through your shirt or whatever, you now are a much better path for the electricity to flow through than if you're dry. So the probability of you getting shocked is much higher when you're soaked in sweat. Your conductivity is higher, that's why. So it's in your best interest to try and stay reasonably cool and reasonably dry. Anytime that I've been shocked, typically with AC, so AC stick welding or AC TIG, it's always when I'm leaning on something, I'm sweating, and all of a sudden, boom, I get nailed. And with TIG, it's actually common that the filler rod becomes part of the ground circuit. I have had it numerous times where I'm dabbing filler material in, the back of the rod touches something, the arc uses, the rod is the ground, and next thing you know, the rod's smoking in my hand for a second and I can burn my fingers, but it also could use my hand as a ground down to the table. So again, all those things you want to consider. So stay dry, no metal crap on you, trust me on that, and wear acceptable clothing. Now there's a couple more things worth mentioning regarding that. The individual that sent me my question for this video was talking about floor pans. It would be very easy in that situation to get shocked. And let's look at this with the MIG process. So say I'm welding over here, my ground is over here. If I have this here, okay, ideally the ground path that would be taken would be straight. But if you remember, electricity flows like branches of a tree and takes multiple paths. Well, all it would take is for some disconnect at any point between here and here, momentarily, to where if you're resting your hand here, that it may go through your glove or through your hand or through your shirt, cut through here and then back. All it takes is a momentary disconnect here. That could be something, it sounds stupid, but say you're welding a floor pan in and you have one tack on it and it's not really touching anywhere else, and then you're welding, that tack breaks or you somehow momentarily break it, and it has no easy path to ground, it will use you. Now, the resistance of your body with gloves and a shirt on is pretty high, much higher obviously than steel, so the probability you taking a really solid hit is fairly low with the MIG process, but it still could happen, and you don't want that. So a way to solve that is what I said earlier, is that if your ground cable's over here, it wouldn't hurt to put cable to here, and now as you're welding, even if it's taking this path or if it's taking this, it gives the electricity a low resistance path to complete the circuit, whichever polarity you're running, to reduce the chance of you getting shocked. So again, like I said, in that auto body situation, having a multiple ground path will just lower the probability of you being part of it. The other thing you want to concern yourself with is what exactly are you welding with? And what I mean by that is if you're using an old school big ass transformer stick welder that has 80 to 100 volt open circuit and you got almost unlimited amounts of power behind it, the probability of you getting shocked with that goes through the roof. Same thing to be said with old engine drives and even some of the modern engine drive generator welders. They produce so much voltage that the probability of you becoming part of the ground path is exponentially higher. Like MIG, open circuit for most MIG welders is somewhere between 30 and, I don't know, maybe 50 volts, somewhere in that. And then you only operate at like 18 to 24 volts, generally speaking, for home hobby machines. Well, stick welding, very common, 80 volt open circuit, 35 volt running. The probability with stick of being part of the ground system, very much higher than MIG, and TIG only operates at like 12 to 20 volts, and then open circuit typically in the 30 to 50 volts. So again, that's far less likely to put you as part of the path of ground. You still can be. Now, I didn't mention it before, and I just thought of it now. Not only can your sweat cause you to become more conductive, if it's pouring rain out and you're out welding in some ditch or on something that's wet, guess what's going to happen? You're going to get shocked more than likely, especially if you're doing it with an engine drive welder that has 80 volts open circuit. The probability you striking an arc and boom, getting nailed very high. That's how I've been shocked before. And luckily I'm still here, so that's a plus, but you get the idea on that. Also with AC TIG welding with AC requires a background high frequency pilot arc, it's called, to maintain an arc, because on AC with TIG, you're basically pulsing between positive and negative polarity. Well, when it crosses 0 volts, there's no arc established. So in order to make AC TIG work, you have to have a pilot arc in the back. That pilot arc operates at high voltage, high frequency. So it's very common to shock yourself with AC TIG when you're welding on something, because the resistance of your skin and your clothing, like high voltage, high frequency, doesn't give a shit about that. Like, it'll jump right through your clothing without even a second guess. Now, the shock you get from that isn't like, oh my God, it'll lay you out, but it's enough to wake you up. I mean, it's almost, like putting a fork in an outlet like you did when you were a kid, or at least I did that, and it's no fun. So it's enough to wake you up, but it's something to be aware of. So again, it all goes back to wear decent clothing, proper PPE. I don't want to harp on you guys about this stuff, but how many times do you want to get shocked before you learn something? And you should do it anyways. I don't care if you weld in flip-flops, sandals, and a t-shirt, but, just at least admit to yourself you're being stupid as hell doing that, So anyways, let's go to conclusion. So hopefully this information helped you, at least gave you a little bit better idea, maybe exposed you to some things that you've never seen or heard of that could be helpful to you. But really, at the end of the day, just be smart about stuff. Wear your damn PPE, ground stuff appropriately, clean your grounds where the clamp attaches, and try hard to not put any part of your body between what you perceive is the completed electrical circuit. So in the case of what you see here, your hand probably shouldn't be resting right here while you're welding something right here. When you put any part of your body between at least the visible path, you're asking to get shocked. I mean, if you rest your elbow over here and you're welding here and the ground's here, what's the probability of it going and completing the circuit there? On this table, none. I mean, it's not going to take that path. On something else you're welding where the circuit could be somehow broken or not existing the way you think, so the circuit isn't clean between here, like between maybe multiple auto body panels, well, guess what? Higher probability. It's also worth mentioning that you should probably inspect your cables from time to time to make sure that the jacket isn't tore up, or same thing with your MIG gun. Like, pay attention to that stuff. Like, it doesn't take too much where this sucker could get a cut, could be resting somewhere you don't see it, or you could unfortunately be touching it, and next thing you know, you find out what it's like to fly a kite in a rainstorm with a key on it. Don't be the key. All right, with that said, I think you guys have a good idea of this, and most of you probably, this is redundant, I get it, but I'm hopefully providing some information to help you become smarter and less likely to get shocked. So with that said, if you got any comments, questions, tips regarding this, feel free to leave them. Until next time, thanks.